Hi, it's Moser, back with your Introduction to Solutions. By the end of this video, you should be able to 1. Describe the components of a solution, and 2. Identify some of the most common types of solutions. Now, before you begin this, you should already know what a mixture is and some of the basic properties of states of matter. You probably know that stuff from physical science. So what is a solution? Well, you might think that it's the answer to all your problems. Well, yeah, but not this time. At its simplest, a solution, it's a mixture. It's a homogeneous mixture. And of course you remember that homogeneous means the same throughout. Well, it's a homogeneous mixture that's got 2 or more substances that are in a single phase. Phase means state of matter. So everything in a solution is going to be in the same state of matter, and it's going to be distributed evenly throughout. It sort of starts to look like a single thing, but it's not. The materials are still distinct and can be separated. It's still a physical mixture. With solutions, we talk a lot about the concept of solubility. And solubility is a substance's ability to be dissolved. Dissolving, in the most common sense of the word, is when particles leave their solid and become uniformly distributed into a liquid. So if we take this pile of sugar or salt or whatever this is, and we put it into the liquid that we've got, and they begin to spread out, and pretty soon you can't see any of the solid pieces anymore. They become less and less apparent. The mixture may look cloudy for a little while, and then eventually it all looks perfectly clear. Those solid particles have left their solid form, and they've become permanently, evenly distributed in the liquid. Okay, in this, the most common kind of solution, the solvent is what we call the liquid we start with, the thing that does the dissolving. The solute, on the other hand, is the solid particles, these guys, which get dissolved in the liquid. If we think about making a pitcher of Kool-Aid, water is the solvent, the solutes are the sugar and the Kool-Aid powder. And water is a very powerful solvent. It's often called the universal solvent, but it's not the only solvent. We can dissolve things in alcohol, we can dissolve things in gasoline, we can dissolve things in any liquid. Again, this is the most common case where our solution is made up of a liquid solvent and a solid solute. That being said, solutions can, in fact, be in the solid, gas, or liquid phase. It's only necessary that everything be in the same phase of matter. The other really important point to note is that in order to consider it a solution, those particles have to stay suspended. They have to stay in solution once they're dissolved, without any further action from you. So when you make a pitcher of Kool-Aid and you put it in the refrigerator, if you go back tomorrow, it should still be Kool-Aid. You shouldn't have a layer of sugar and Kool-Aid powder at the bottom with water on top of it. That would not be a solution. And it also wouldn't be very good. We can have something like pop. That's a solution. And it's made up of water, that's the solvent, sugar, flavorings, and a gas. Yeah, there's CO2 that is in solution in the pop. Now, that comes out very often when we open the lid and we hear psst. That's the CO2 escaping. But during the time that it is in a sealed vessel, all of the components are in the same phase. Therefore, it's a solution. We can have a solution that's composed of solids, and we typically see these in metals. They're called alloys. When the characteristics of one metal aren't really totally up for the job, we mix a few metals, we get a solid solution, and we go with it. If you have a piece of gold jewelry, it's not pure gold. Pure gold is so soft that you could bend it and snap it in half. So gold is typically mixed with silver or other metals to make something that's a little bit more durable. What other kinds of solutions can you imagine? Well, you're sitting in one right now. The air around you is a solution comprised of nitrogen gas, oxygen gas, carbon dioxide gas. and a few other very minor gases that we don't talk much about, the weirdos like argon and stuff. Now, fortunately for us, the atmosphere, the solution that we walk around in, is pretty evenly mixed. If it wasn't, you would have the risk of walking into a CO2 pocket or a nitrogen pocket and dropping over dead. The oxygen is evenly distributed within those other gases, so every time we take a lungful of air, approximately 20% of the molecules that we inhale are oxygen. Whew, that's convenient. Now, because we said that in the sort of classic solution where we take a liquid, we dissolve a solid into it, the liquid is the solvent, the solid is the solute. This changes a little bit when we've got things like solid solutions or entirely gaseous solutions. In those cases, we usually consider whatever there is more of to be the solvent, the predominant ingredient, as it were. So in our atmosphere, of course, nitrogen is the principal atmospheric gas, comprising over 70% of our atmosphere. In that atmospheric mixture, we would consider nitrogen to be the solvent. In a 14-karat gold, which is actually more silver than gold, we would consider silver to be the solvent into which the gold is being dissolved. Now, there are a number of things that are related to solutions. There are suspensions, which are almost solutions, but the particles are too big to stay suspended. So when you stop stirring, the particles tend to fall to the bottom. If you think of a pitcher of muddy water or sandy water, you can stir it, the particles will stay suspended, but when you stop adding energy, they fall to the bottom. There are what are called colloidal solutions, in which the particles stay suspended, but they don't actually completely dissolve into the liquid phase. These aren't true solutions, so they get called colloidal solutions. And if you think of gravy, gravy is a colloidal solution. The one that is really important that we're going to talk about briefly is what's called an electrolytic solution. In an electrolytic solution, the neat thing is, if we run current through the electrolytic solution, it'll conduct electricity. This is because of the presence of charged particles, generally ions, in an electrolytic solution. Gatorade is an electrolytic solution. When they say that you need to replenish your electrolytes, they're talking about ions like sodium and calcium and magnesium. Principal ingredient in Gatorade? Salt, which breaks down into sodium and chlorine ions. Pure water will not conduct electricity. However, water that's full of dissolved ions will conduct quite nicely because it's an electrolytic solution. Not all things that can be dissolved in water will conduct electricity. Sugar, for instance, will just yield neutral molecules in a solution, like your pitcher of Kool-Aid. Add salt to it, however, and you can cook. When we have a substance that breaks down into ions or charged particles in the solution, those are called electrolytes, just like they advertise being in Gatorade. Because of the fact that those ions will pass charged particles, electrons, from one to the other, the whole solution ends up conducting electricity. If you've got something that will not conduct electricity when dissolved in water, that's called non-electrolytes, or a non-electrolytic solution. Okay, to recap, solutions are just homogeneous mixtures with two or more substances, all in a single phase. And they're created by dissolving solids, most often, into liquids, where particles will leave their solid form and become universally distributed in the liquid. And the ability of a substance to be dissolved is called its solubility. In the oldest, most traditional sense of a solution, we talk about the solvent, usually the liquid, and the solute, usually the solid. However, because there are some special cases where we have gases dissolved in liquids, or metals dissolved in one another, or gases dissolved in one another, we sometimes also look at what there is the most of and consider that to be the solvent. Suspensions aren't really solutions, but they'd like to grow up to be. Colloidal solutions aren't really solutions either, but they're a whole lot closer. And electrolytic solutions are pretty darn important. in the bodies of organisms such as yourself and in all kinds of applications around the world, because electrolytic solutions conduct electricity. Okay, that's it. Take your quiz.